Section 10.1, we're going to talk about properties of exponents. And we're going to have a long list of rules for exponents. I'm going to start a list here. Rules for exponents. And we're going to let A and B be any numbers. And we're going to let M and N be counting numbers. So what are counting numbers? What do I mean when I say M and N are counting numbers? What are the counting numbers? If you're going to count, you go 1, 2, 3, 4, 5. Those are the counting numbers. Okay, so rule number 1. Don't know how many rules we're going to have here. We're going to have a whole bunch of them in the end. What if I take B and I raise it to the power M, where M is a counting number like 1, 2, 3, 4, 5. What does it mean to take something and raise it to a power? Multiply it by itself M times. So this means B times B times B times B. And we have M factors here. All right, so I'm going to leave some space to keep writing my list here. I'll start some examples down here. So this is no surprise. I think if I asked you to do 2 to the third power, you would tell me 2 to the third power is 8, because 2 to the third stands for 2 times 2 times 2, which is 8. And if I did 3 to the fifth power, you would tell me 3 to the fifth power is 3 times 3? 9 times 3. 27. 27 times 3. Here's the easier way to do this one. This is what it means, right? So what's 3 times 3? 9. And here's another 3 times 3. That's also a 9. What's 9 times 9? 81. So this is 81 times 3, which happens to be, well, what's 3 times 1? 3. What's 3 times 8? 24. So this is 243. How do you do that on your calculator? How do you do 3 to the fifth on your calculator? 3. And then what's the exponent button? It's called caret. It's this little thing here right above division. And on my calculator, I have the newer operating system. It actually puts the 5 up there as an exponent. If you have an older calculator, it actually draws the caret symbol and then puts a 5, and you hit enter. 3 to the fifth is 243. All right, so there's rule number 1. No surprise on rule number 1. Rule number 2. What happens if I have a base raised to a power and I multiply by the same base raised to a different power? We usually use B here. B stands for base. M and N are called the exponents. So an example of that might look like, what if I asked you to take 2 cubed and multiply it by 2 squared? Well, what does 2 cubed mean? It means 8. It also means 2 times 2 times 2. And then what does the 2 squared mean? 4 or 2 times 2. So what do you have? You have 2. How many times? 5. That's 2 to the fifth. So when I had a base raised to a power, and I had the same base raised to a different power, what did I do with the exponents? I I added them. 2 plus 3 gives 5. So that's rule number 2. Rule number 2 says when you're multiplying things together, you add your exponents. All right, so again, for examples, you're going to see things like x to the 5th times x to the 8th. You would tell me that x to the 5th times x to the 8th is x to the 13. You simply add your exponents together. X to the 13. How about if I gave you 3x squared times 5x to the 4th? How would you simplify that? You multiply the numbers. 3 times 5 is 15, and then you add the exponents, x to the 6. Excellent. Very good. Questions on that one? All right, rule number 3. What happens when I divide? Again, the bases are exactly the same. What has to happen?
Cancel. You subtract exponents.
It would make a lot of sense that you would subtract. When we multiplied, we added exponents. It would make an awful lot of sense that when we divide, we subtract our exponents. And that is exactly the right rule. I'll give you an example here in a minute of why that works. We do have to have one little extra condition here. And the one little extra condition is b cannot be the number 0. How come b cannot be the number 0? 0 to an exponent is 0. And what's wrong with that?
Irrational.
No. Worse than irrational. Can you have 0 down on bottom of a fraction? No. What happens when you have 0 on bottom? It's not 0. It's undefined. You can never have 0 on bottom of a fraction. So b cannot be the number 0. If b is the number 0, I have 0 on bottom. That's undefined. All right, so this is going to look something like this. First off, I'll show you why it makes sense we subtract. Somebody said it, because stuff cancels. If I had 3 to the 6th divided by 3 to the 4th, for example, I could go ahead and write this out. 3 to the 6th would mean take the number 3 and multiply it by itself 6 times. So I'd have 3 times 3 times 3 times 3 times 3 times 3. While 3 to the 4th would mean have 4 3's down on bottom. And what happens? They cancel. So that 3 cancels, those cancel, those cancel, those cancels. What's left over? A couple of 3's, right? Again, notice if I take my exponents, if I take 6 minus 4, I get 2. So that's why that rule works. Things cancel out. All right, so you're going to see problems in your homework like this. You might have x to the 12 divided by x to the 9. You would tell me that x to the 12 divided by x to the 9 is x cubed. Okay. What if we had 12x to the 5th divided by 18x squared? What would you do with that one? Well, start with the numbers up front. Can you reduce 12 over 18? Yeah, what do 12 and 18 have in common? Bigger than 3. Bigger than 4 doesn't go into 18. 6. 6 goes into both 12 and 18. So I divide top and bottom by 6. That's going to give me a 2 and a 3. And then how about the x's? You subtract your powers, you end up with x cubed. 5 minus 2 is 3. All right, how about 4x cubed times 6x to the 6th divided by 15x squared. How would you simplify that one? You start with the top. That's exactly right. So you multiply. 4 times 6 is 24. And then how about your x's? X to the 9. You would add those exponents, x to the 9. Divided by 15x squared. 24 and 15, anything in common? Can you reduce? They reduce by 3. So that's going to be 8/5. And then how about the x's? 9 minus 2 is 7, so we have x to the 7th. Questions on that?
Does the x to the 7th have to be written up top? Or is it?
No, you could write it this way also. It could be written as 8/5 x to the 7th. You could write it that way also. That would be fine. Other questions? Okay, how about this one? What if I gave you x cubed over x to the 4th? What happens there?
Goes negative.
You subtract your exponents, so you could go ahead and subtract your exponents, and that would give you x to the, you subtract your exponents, what's 3 minus 4? -1. So you could get a negative exponent. On the other hand, x cubed over x to the 4th, we would have 3x's divided by 4x's. We would cancel out a bunch of x's. What do you have left over? You have an x left over, but where is that x? It's on the bottom. So that means that x to the -1 has to be exactly the same as 1 over x. In other words, what happens when you have a negative exponent? I can take that negative exponent and I can make it positive. The penalty is it moves to the bottom. Questions on that? All right, so that's our next rule. Our next rule is b to a negative power. We get rid of the negative power by putting the b on bottom. And then the power becomes positive. And we have to have the same little rule here. B can't be 0, because if b is 0, once again, I would have 0 on bottom, and that's no good. Okay, so you're going to see problems like this, problems where you have negative exponents also. Let's say I gave you x to the 4th times x to the -6. What would you tell me x to the 4th times x to the -6th is? You would add your exponents. You would tell me it's x to the -2. But the directions in the homework and the directions on the quizzes and the directions on the test will always be write your answers only using positive exponents. In other words, what do I want you to do with that x to the -2? Put it on the bottom. So your final answer would be this is 1 over x squared. A negative exponent, if it's up on top, it just moves down to the bottom. Questions on that? Okay. How about 15x cubed divided by 5x to the 8th? Well, 15 over 5, that is 3. X to what power? Negative 5. Once again, the directions will be write that only using positive exponents. How would you write that only using positive exponents? All right, that's a very common mistake. This is wrong. 1 over 3x to the 5th. Very common mistake that people will make. That's wrong. What's wrong with that? What's that? No, there's no more negative. The x to the 5th has a positive power now.
To move the 3 down, you have to change to -3.
Closer. You wouldn't change it to a negative 3. Where's the exponent? Is the exponent on the x? Is it on the 3 or is it on both? It's just the x. In fact, what's the exponent on the 3? If we don't write it, it's a 1. So what should move? Just the x moves. And it's a very common mistake. It's very common to think the 3 and the x are connected. They are. They're connected by multiply, but the order of operation says you do powers first. And that power is only on the x. So the correct answer is only the x should move. 3 over x to the 5th. If I were to move the 3 down to the bottom, I could, but then I would have to have a 3 to the negative 1, x to the 5. In order to move the 3 down, its exponent would have to change. But I don't want to write it that way. Why not? Because then I have a negative exponent. So again, this isn't wrong, but the computer will mark it wrong when you go to do your homework online. And that one's definitely wrong. This is the way we would write our answer. Only the x moves. The 3 does not have a negative exponent on it. All right, one more of these. How about negative 8, x to the 4th, y to the 6th, let's put some more letters in here too, divided by 4, x, y to the 10th. What's negative 8 divided by 4? Negative 2. What's x to the 4th divided by x? X cubed. What's y to the 6th divided by y to the 10th? Y to the negative 4. How do you rewrite that so that your negative exponents are gone away? Negative 2, x to the 3rd over y to the 4th. Excellent. How come the 2 didn't go to the bottom? Doesn't it have a negative? That negative is not an exponent, is it? It's just a negative number. That's just a regular old number, negative 2. There's no exponent on that 2. Well, there is an exponent. It's a 1. So it does not move. And again, that's a real common mistake. People will see that there's a negative out in front of this 2. They'll want to move that to the bottom. It doesn't move. Its exponent is a 1. Only the y has a negative exponent. It's the only one that moves. Questions on that? What if I had a negative exponent but that negative exponent was already on the bottom? How would I get rid of it and make it positive? Just bring it up. How come? It's the inverse, that's correct. Or the answer I like better is this would be 1 over 3 to the negative 1 means the 3 should be on bottom of a fraction. So 3 to the negative 1 is a fancy way of saying 1/3. How do I take the number 1 and divide it by a fraction like 1/3? How do you divide by a fraction? flip and multiply. So this is 1 times 3 over 1, which is 3. All right, so that's rule number, I forgot what number we were on here. That's rule number 5. Rule number 5 says if you have a negative exponent and it's already on the bottom, it simply comes to the top. And once again, we have to have the rule b can't be 0. B can't be 0 because, again, I would have 0 on bottom over here, and that would be a problem. All right, so you're going to see problems like this. You might have something like x to the negative 2, y cubed, z to the negative 5, divided by x cubed, y to the negative 2, z to the negative 2. What might you do? Okay, there's two ways to attack this one. Way number 1 is to subtract the exponents. So I'll do it way number 1 first. I take my x's. I take negative 2 minus 3. What's negative 2 minus 3? 1, no.
Negative 5.
Negative 2 minus 3 is negative 5. X to the negative 5. I go to my y's. I subtract. What's 3 minus negative 2?
5.
That one's 5. Y to the 5. And finally the z's. Negative 5 minus negative 2. Negative 7. Nope. Negative 3. All right. And what we saw is, this is why I don't like this method very much, because people have issues subtracting negative numbers. But it does give the right answer. The right answer would now be the y to the 5th is going to stay on top. The x to the 5th goes to the bottom. And the z cubed goes on bottom. So there's one way to do it. If you are confident with your ability to add and subtract positive and negative numbers, that's probably the quickest way to do it. But we get a lot of mistakes. So here's another option. X to the negative 2, y cubed, z to the negative 5th, divided by x cubed, y to the negative 2, z to the negative 2. What I prefer to do is move the things that need to move. What do I mean, move the things that need to move? What's this x to the negative 2? What does that negative power tell me to do to that x? Move it to the bottom. On the other hand, this x cubed, this one has a positive power. It doesn't move at all. So negative powers move, positive powers don't. So I'm going to move the x squared down, and I'm going to leave the x cubed right where it is, because it already had a positive power. What about the y's? What's going to stay and what's going to move on the y's? The top one will stay, y cubed stays, and then y to the 2 moves. The y to the 2 has a negative power, it moves to the top. How about the z's? They both move. Z squared, z to the 5th. My experience has been when students do it this way, when they get rid of all the negative powers first, they more often get the right answer. So this is my suggestion on how to do it. Now this way does take a little longer. I think it adds an extra step, but you get the right answer more often. All right, so now I deal with my y's. Well, I guess I'll do my x's first. What would I have with my x's? X to the 5th, but where is it? On the bottom. X to the 5th is down on bottom. How about the y's? Y to the 5th, and it stays right on top. How about the z's? Z to the 3rd on the bottom. Excellent. Why is it z to the 3rd on the bottom? Other than that's what we got before and we want to get the same answer. You subtract. 2 minus 5 is negative 3. Since you got a negative, it's going to go to the bottom. So there's the right answer. So there's two different ways to do that problem. The way you should do it is the way that was better for you. Doesn't really matter to me. But again, my experience has been if you get rid of all the negative exponents first, you more often get the right answer. All right, we got 2 more rules, I think, for today. I have more rules on Wednesday. Number 6. Six kind of has 2 parts. Kind of go together. What happens if you have 2 things multiplied together inside a parenthesis and they have a power on them? They all get that power. So that's a to the m, b to the m. And how about if you're dividing 2 things and they have a parenthesis around them and it has a power? They both get the power. A to the m over b to the m. And of course this one, b can't be 0. And then finally, rule number 7. What if something has a power and then it's inside a set of parentheses and then there's another power? You multiply the powers there? Yes, why? Because that's the rule. Yeah, that's the answer people usually give. I'll give you an example of why that should be the rule. Oh, so anyway, maybe I went too fast. Give me a second to write those down. Okay, so why should rule number 7, well, we'll do the number 6 and number 7. If I have, for example, 5x cubed squared, well, by definition, that means to take 5x cubed times 5x cubed. What's 5 times 5? 25, which notice that happens to be 5 squared. That's 25. And then what's x cubed times x cubed? X to the 6. And notice 3 times 2 gives 6. So that's why that works. When you have a power followed by another power, you multiply. 3 times 2 is 6. Questions on that? Okay, so last one of these crazy examples. What if I gave you 2x squared cubed divided by, hold on me, I'm running out of ideas here. Give me a number.
4x.
4x, okay. Let's make it 4x to the negative 3. Put a negative power in there somewhere too. Well, you would start with the top. And what would you tell me you have on top?
3x squared.
And 2 cubed is 8. And x squared cubed? You multiply those powers, x to the 6. Divided by 4x to the negative 3. Oh, I don't think I'm going to need a fraction anymore. Although I wrote a fraction bar, I don't think I'm going to need it. Because 8 divided by 4 is 2. And x to the 6 divided by x to the negative 3? Not x to the 3. X to the 9. Why x to the 9? Again, 2 ways to do it. 6 minus negative 3 is 6 plus 3, that's 9. Or you think that this negative power comes up to the top and that gives you an x cubed up on top. And an x cubed times an x to the 6 is an x to the 9. Again, watch your signs there. That's the biggest mistake people usually make is they mess up their signs. All right, now what are all these exponents good for? Well, the main use we're going to have in this section is something called scientific notation. And I'm guessing most of you, if not all of you, have seen scientific notation before. What's scientific notation?
Really long.
It's really long? I don't think it's really long. And a lot of times I think it's much shorter than not scientific notation. What do you use scientific notation for? It deals with multiplying by tens, that's correct. What's it used for? It's used in science, that's why it's called scientific notation, that's true. How is it used in science? Yes, it's used for either really, really big numbers or really, really small numbers. And here's the idea. What happens when I take 4.2 times 10? You get 42. What's 4.2 times 10 squared? Well, 10 squared is 100. How do you take 4.2 and multiply by 100? And what do you get? 420. What's 4.2 times 10 cubed? 4,200. 10 cubed happens to be 1,000. So what does multiplying by 10 to a power do? Well, multiplying by 10 to the 1 moved the decimal one place. Multiplying by 10 squared moved the decimal two places. Multiplying by 10 cubed moved the decimal three places. So what if I gave you 4.2 times 10 to the 8th? How would you write that? You move the decimal 8 places. So it's going to be 4, 2, and then I got to move 7 more places, so I need 7 zeros. 1, 2, 3, 4, 5, 6, 7. So that's a fancy way of writing 42 million. So here's where scientific notation comes into play. If you take a chemistry class someday, you might deal with this number quite often. 6.02 times 10 to the 23rd. Anybody know what 6.02 times 10 to the 23rd is? It's the number of molecules in a mole. That's correct. It's called Avogadro's number. Would you prefer to write 6.02 times 10 to the 23rd, or would you like to write 602 followed by 21 zeros? Yeah, I think this way is much nicer, isn't it? 6.02 times 10 to the 23rd. What if you have negative exponents? Positive exponents move the decimal to the right. What do negative exponents do? Move it to the left. So if I were to give you 0.00035, how would you write that in scientific notation? That's a correct answer, but that would not be considered scientific notation. For scientific notation, this first number has to be between 1 and 10. So we would write it as 3.5. He said write it as 0.35. Not wrong. He didn't give me a wrong answer, but it wouldn't quite be scientific notation. So we would write 3.5 times 10 to the -4, because I'd have to take the decimal and move it 4 places to the left. Or how about 2.35 times 10 to the -6? How would you write that as a decimal? How many places do I move the decimal point? 6. So I'll move it here is 1, and then I got to go 5 more. So I need a decimal point, 5 zeros, 235. That's how you would write that in standard notation. All right, your calculator does do scientific notation. It does it very well. So if I wanted to type in 6.02 times 10 to the 23rd, I would type it in as 6.02 times 10 raised to the 23rd. And if I hit enter, it writes this. So this is the calculator's symbol for notation. 6.02 E23. What does that E mean? It means 10 to the 23rd. So if you ever take your calculator and you have like a really small number, like if you do, I don't know, 25 raised to the -6 maybe, your calculator quite often will put that in scientific notation. So how would we write that in standard notation? 0.804096. And if you're using your calculator and you go to do MyMathLab, if you write 25 to the -6 is 4.096 E -9, MyLab unfortunately will mark that wrong. You need to write it as 4.096 times 10 to the -9, or it will mark it wrong. It doesn't understand the calculator's notation. Questions on that?